Hello, I'm Nancy Strickland from IT Mentors. This video is part of a series on the Beta 2 release of Visual Studio 2010 and the .NET Framework 4. Both C# and Visual Basic .NET have new features in Visual Studio 2010 and the .NET Framework 4. This session explains and demonstrates those features in the context of Office programming. So I'll start with a quick explanation of what Office programming refers to, and then I'll cover these three new features of C, named and optional arguments, dynamic return values, and some Comm programming changes. And then I'll talk about some features that are new to Visual Basic, auto-implemented properties, statements in Lambda expressions, and collection initializers. And I'll explain a new feature that affects both languages, which is embedding of type information. There are several new features in C# and Visual Basic that have been introduced in Visual Studio 2010, the ones I just mentioned in the agenda, and those features can be used in any kind of programming where you might need them. But in this video, we're going to look at them using Office programming. Office programming means using the Microsoft Office development tools that are part of Visual Studio 2010 to create .NET applications that extend Office. Those kind of apps are called Office solutions. The tools include project templates for creating Office solutions with Visual Basic or C#, and visual designers for creating custom user interfaces for your Office solutions. You'll also be able to use those tools with the newest version of Office, which is Office 2010. It's scheduled to be released early in 2010, but you can get a fully functional beta of it now if you want. The URL to download the beta is in the resources that I'm giving you at the end of this video. But in this video, I'm going to use Office 2007. I'm going to start by looking at the new features in C, named and optional arguments, dynamic return values, and Comm programming changes. Named arguments let you provide arguments by name instead of by position in the parameters list. Optional arguments let you omit some arguments for some parameters. Both mean that you can provide only some of the parameters to a method, which make it much easier to work with Comm interfaces like the Microsoft Office Automation APIs. Named arguments can make it easier to call a method because if you don't remember the order of its parameters, but you do know their names, then you can just use the names and then the order doesn't matter. Here's the syntax. You provide the parameter name followed by a colon, followed by the value, and you comma separate your arguments as usual. Obviously, as you can see right here, this can also make it easier to read your code. In C# 2010, when you define a method, and that includes constructors and indexers and delegates, you can specify that one or more of its arguments are optional. And then when the method's called, the caller can leave out the arguments for any of the optional parameters. Now, to do this, obviously the method code has to provide a constant to be the default value for any optional parameters. The optional parameters also have to be last in the parameter list, rightmost, after all the required parameters. And if a caller provides an argument for any optional parameters, then it has to provide arguments for all the optional parameters that are in front of that one, because otherwise you'd have to leave a blank in the argument list. But you can combine optional arguments with named arguments to get around this. So in this example right here, the caller would only have to provide one integer value. And in that case, the second integer would default to 36, and the string would default to Bob. But the caller could also choose to supply the second integer value, 412, or both integers and the string, 412 and Emily. The caller couldn't skip the second integer, though, and just provide 4 and then an empty thing there, and Emily, or just 4 and Emily. But as I said, there's a way around this, which is to provide a named argument for that third parameter. So I could say myMeth4, comma, and then name Emily, and then the compiler would take that. Named and optional arguments make it easier to work with Comm APIs like the Office Automation APIs. For example, there's an auto format method in the Microsoft Office Excel range interface, and it's got 7 parameters. Now, before C# 4 which is the 2010 version is C# version 4, you had to supply all 7 parameters. So you can see what a long call that was. But now they're all optional. So you can just use the defaults, or you can change only those you want to using named arguments, like in this second example. Not only is it less typing and you're eliminating just type missings that have no meaning anyway, but it's also a lot easier to read. It's more common these days for programmers to have to deal with dynamic data, data that's not known by value or even by type at compile time. That data might come from a dynamic language like IronPython or IronRuby, or maybe from the HTML document object model, the DOM, or from other places. The point is that this can be a problem in a statically typed language like C# and others. So C# 4 has introduced a new data type, dynamic. It's a static type, so a static compiler like 4 can accept it. Objects can be dynamic, and so can primitive types. But at runtime, the type of the object will be known, and C# will treat it appropriately. And that means that code that compiles could still fail at runtime if you're treating it like a one type and it comes in as a different type. But basically, the dynamic type lets operations that include dynamic types skip compile time type checking, and then they get checked at runtime instead. So using it can make it easier to work with dynamic data, like from IronPython or IronRuby libraries, or with the HTML DOM, like I said earlier. But it can also make it easier to work with Comm APIs, like Office Automation APIs. So the dynamic type can make your apps more Comm friendly. And that's because many Comm methods have argument types or a return type that's specified as an object rather than a specific type to allow for more flexibility. But if you're working in C#, then you have to cast those values back to an actual type, to the correct type, so that the methods you need to use on them can be used. But now those object variables in Comm method signatures can be the dynamic type, and that avoids the cast. The code will compile with the dynamic type without any type checking, and then at runtime, the actual type that's there will be handled appropriately. So here's an example. The first code here shows using the cells property of an Excel spreadsheet object. That property returns a range object, but you can see that I have to cast it to a range to use it. Then the second example shows the simpler, cleaner code that you can use if you don't have to do the cast. So the conversions to an Excel range are now being handled by the runtime Comm binder. Also, in C# 2010, there's some changes in Comm programming to make things just a little easier. First of all, you can leave out the ref keyword. In other words, if a Comm method has reference parameters, you used to be required to pass those with the ref keyword, and now you can just skip it. You can also use indexed properties. In earlier versions of C#, methods could be accessed as properties only if the get method had no parameters and the set method had exactly one value parameter. But in Excel, for example, the range property has a get that requires a parameter for the name of the range. And that kept you from using range as a simple property, so instead you had to call this getRange method like it shows here. And the same is true of the set property. It required two arguments, a value and a type, so you used to have to use a setValue method. But now you can just use a property. So the first example shows getting and setting a range with a method, and the second shows doing it with a property. Notice again that the new version is simpler and cleaner, and the second version there, the second example, also shows that you can leave out that optional property. And those features, they already existed in Visual Basic, but now C# has them too. And now let's see what's new in Visual Basic. There's auto-implemented properties, multiline lambdas, and collection initializers. Auto-implemented properties let you just specify a property of a class. You don't have to explicitly code the get and the set. The compiler automatically creates a private field for the property and a get and a set for it. You can also set a default value at the same time, and it's just as simple as what you see here. Now, of course, if you want something more than a simple property, if you want to add validation code to your set, then you'll have to use a regular set procedure and write out the code yourself. And that's also true if you want to use a different access level, like making a get or a set private instead of public, or if you want to make something read-only, and a few other circumstances. If you need full documentation on that, check MSDN for auto-implemented properties in Visual Basic. And then on the resources slides that are later in this video, I've given you a URL for the page on writing Office solutions in Visual Studio 2010. A lambda expression is a little function or subroutine without a name. It's sort of an inline mini function, so it's typically short and simple, and since it's inline, it doesn't need a name. You can create a lambda expression with function or sub, but they're always included in a statement. So you can see in this first example that there's a lambda expression that's embedded inside that right line statement. The function has no name and no in-function statement. It doesn't even have an explicit return statement. The value that's returned by the single line function is the value of the expression in the body of the function, which of course is num plus 1. Now, it doesn't have, as I said, an explicit return type. The type is inferred by the compiler. So if it's taking in an integer and it's performing an integer add, then the compiler infers that the return type has to be an integer too. Now, this function, this lambda, is going to operate on the 5, so this console write line will print out 6. Now, the advantage to using a lambda in this case is that I didn't have to go to the trouble to create a separate named function in order to increment its argument by 1 and then call it. There's just less coding involved if I just build the function right where it's needed. Now, of course, this only makes sense if it's a one-time only function. If I'm going to be using it in several places in my code, it's worth writing it out as a separate function so that it can be called instead of being written out every time. And of course, writing it as a separate function lets you also maintain it in just one place. And it also usually makes the most sense if it's a fairly short little function. If it's too complex, it can make it messy to write inline and be hard to read and hard to maintain too. You can also assign a lambda to a variable and then use the variable name like you'd use the function name, like in this next example here. It shows you what a multi-line lambda looks like. You can see that it does have the return and the end function there, but the function's type is still inferred, and that's what's new in VB 2010, lambdas with more than one line. Being able to have more than one line means the lambda can include full statements, not just a single expression that's the return value. And we'll see an example of that in the demo in a minute. And then these last two examples are there just so you can see what a lambda that's a sub looks like, and you can see that it can also be written as single line or multi-line. Collection initializers are an easy way to create a collection and then initialize it at the same time. They're handy when you're populating your collection with a little set of values like the names of the months or a list of menu items. The syntax is something like what you use for an array. You use curly braces and you comma separate the individual values. If you're creating a list of classes, then you need to add the type and you use a from keyword here. And now here's a feature that's new to both C# and Visual Basic, embedding of type information. You can use type embedding with any managed solution, but it's frequently used with Comm Interop, like an application that uses automation objects from Office. That's because embedding type information lets the same build of a program work with different versions of Office on different computers. You won't have to deploy primary interop assemblies, PIAs, to the user's computer. A client can embed type information for Office just by referencing the assembly and setting the embed interop types property of the reference to true. And if you're using Visual Studio 2010, when you create an Office project type, that property gets set to true by default. And the great thing is that if Office comes out with a new version of the runtime assembly, the client program won't have to be recompiled. It can use whichever version of the runtime assembly is available that it finds with the embedded type information for the public interfaces that it needs. In other words, references to a PIA, a primary interop assembly, aren't required, and that makes deployment easier. You just deploy the application without having to deploy a specific PIA version too. Before I start, let me tell you that more information on this demo is available from MSDN. I've given you the URL for it in the resources at the end of this video. And let me also say that I'm going to do this demo twice, once in C# and once in Visual Basic, because the new features are different depending on what language you're using. So I'm going to start with C# this time. If you're interested in Visual Basic, you can just skip forward to that demo. I've opened Visual Studio 2010, that's Beta 2, on my Windows 7 PC, and I'm going to start a new project. I'm going to select Visual C. I'm going to select Office. That'll be Office 2007. It also works for 2010, but I don't have that one. And it's going to be an Excel 2007 add-in. Now, notice that I have to be using the .NET Framework 4 for what I want to do, and I can see up here at the top that that is what I'm using. Okay, and this is Office Demo 1. Okay, now I'm going to have to start by adding some references. So over here in the Solution Explorer, I right-click the project name, I select Add References, or Add Reference, and I'll go to the .NET tab, and I'm going to, under the component name, I want to make sure that they're sorted alphabetically so I can find them. So I clicked on that, and then I'm going to go down here because there's so many. Oops, I thought I had that sorted. There we go. Want to come down here to the Microsoft Office Interop Excel and the Microsoft Office Interop for Word. Now notice that there's different versions. I have version 12, which is from Office 2007. That's the one I'm going to add. And the same thing for Word. I'll get version 12 there. And OK, and those should be over here, Excel and Word in my references. And now I'm going to work with the basic code file, which is called thisaddin.cs. Here it is, thisaddin.cs. Up here at the top, you can see that the using statement that I need for Excel has been added already for me because this is an Excel add-in. I still am going to have the using for Word. There we go. Now I'm ready to create a class for a bank account. What I'm going to do is right-click the project, Add, and what I'm going to add is a class. And the name of that class is going to be account.cs. Click Add to get it there. And I'm just going to add a couple of lines of code here so that the account has a couple of properties. So I have a get and a set for an ID. And for a balance, a bank balance. Now I'm going back to my add-in, and in the startup method, I'm going to create a list of accounts with 2 accounts in it, and I'm just pasting it in here to save a little bit of time. So bank accounts is a list of accounts. I've got 2 accounts in it with IDs and balances. And now what I want to do is add a whole new method to my add-in to create a workbook and export the data to Excel. Now it's long, so I'm going to just paste it in like this and then go over it. So let's look at what's here. You can see that this is a method that takes two arguments. It takes a list of accounts, and then it takes an action. The action's name is displayFunc, and that action takes two arguments, an account and an Excel range. And then the body of the sub creates a new workbook, makes it visible in A1, but actually these are titles for the columns A1 and B1, ID and then balance. And then we're going to select A2, and then for each account in the accounts that were passed in, that's the first argument there, accounts, we're going to call that displayFunc method. And remember that that method was passed in as an argument. And the purpose of it, we haven't seen it yet, but the purpose of it is to take an account and the particular cell that's active at the moment and display the contents of that cell, and then it moves on to the next row and continues to do it. And then the last thing it does is it copies all the data to the clipboard. In this case, we're just hard coding the range just to make the code simpler. Now this method uses two of the features that are new to C# 2010. First of all, the add method up here has an optional parameter. You can use it to specify a particular template. You can't necessarily tell that from the code that's here, so let me hover over the method and you can see that it has object template as a parameter, and it's optional. I didn't use it, so this workbook is going to have the default template. Now, if I'd written this code using the previous version of C#, I'd have had to supply an argument here, and I'd have used type missing. And then the second new feature is indexed properties. Like I talked about on the slide earlier, range here uses indexed properties so that you can access its value property here directly and easily. Offset is also an indexed property right here. Now I'm going to use the new dynamic type to avoid having to do some casting when a comm method from Office returns a value. When that happens, C# at 2010 will treat it as a dynamic value, and it does this automatically because embed interop types is set to true, which is its default value in this situation. So I'm adding two more lines, Excel app, and then columns, column 1, and I'm going to Autofit it. And then I'll do the same thing for column 2. Now you can see, I believe you saw, that when I hit the dot here, I didn't get the kind of help that I expect from Intellisense. It says it's a dynamic expression, and although you can't quite see the whole thing, it says this operation will be resolved at runtime. In other words, it doesn't know yet exactly what column 1 is. It's a range, but we don't have to cast it to a range. It'll be resolved at runtime, and then when it's a range, C# will know that Autofit is a method that can work on it, but because we don't have a cast here, it doesn't know that yet. In fact, as far as it knows, Excel app columns 1 and columns 2, those return an object which doesn't support the Autofit method. So in C# before, you had to cast the object to an instance of range so that you could call Autofit, and then this just eliminates that extra coding. Now, one more thing about that. You cannot create indexed properties of your own. This new feature, well, new to C#, VB already had it. It only supports consumption of existing indexed properties. So that's what we're talking about here. Okay, now I'm going back up to this startup method. And I'm going to call the display in Excel method. And that takes two arguments. The first is the accounts to be processed. And then remember that the second argument is the, let me go ahead and put that in there, this bank accounts, right? And then the second argument is the method that's going to be used to display the values. It's an action that gets called in the body of the function to display the contents of the account. But we never wrote code for that action. It's supposed to be passed in at runtime. But instead of writing it separately and passing it in, we're going to write it instead inside the method call itself, in place where that argument goes. So we're going to write it as a lambda expression for processing the data. I'm going to paste in that lambda, and then we'll talk about it here. Okay, it's a lambda argument, so it doesn't have a name, of course. But you can see that it's going to be passed an account and a cell, which is what we said the method should be passed, an account and a cell, a range here. So it's written in line here as one of the arguments right after the bank accounts. Then here's the function. And the syntax is, of course, that you have this arrow, this big arrow with an equals and a greater than symbol. And then here's the body of it. So in the body, it's going to take the account ID and put that into the cell as the cell's value. Then it's going to move over by 1 and put the balance of that account as the value in that cell. And then if the account balance is less than 0, if it's a negative balance, we're going to set the cell interior color to 255, which is red, and we're also going to move over to the one next to it and set it to red also. So right here in the call, where I'm supposed to supply a list of accounts and a method, I'm supplying a variable holding the list of accounts and the actual code for the method right there. It goes right to that. Oops, can't do it there. There's the body, and then this is the closing parenthesis for the call to the function. Now, multi-line lambdas like this are not new to C#, but they are new to Visual Basic in 2010. And that's all. I'm ready to run the program. I'm going to press F5, and it should generate an Excel worksheet for us to display the data from those accounts. There comes Excel. It's going to paste in our information from the accounts. Okay, so there's our information. You can see that it's been Autofit, and you can see that where the balance was negative, it turned it red. Now I'm going to add a little more to the application to show another new feature here. Let me close this for now. Nothing to save there. I'm going to go here. I'm still in startup, and I'm going to paste in a little code that will create a Word document. Here it is, a new Word app, new instance of Word, and then add a new document, and then I'm going to use the paste special method. And the reason I'm using the paste special, that's the reason for putting it here. If you have used the paste special command before in C#, you know that it has 7 parameters, and they're all reference parameters. And to call it, in the past you had to list every single one, even if you were using type missing as your value, and you also had to put the keyword ref in front of each one. So it ended up being a kind of a long call, you know. It went either way over to the right or took multiple lines. But now in C# version 4, I can just ignore the parameters that I don't want because they're now optional. But so that the computer knows which parameters I am providing, I've identified them. So this is a named parameter right here, link true, and display as icon is also true. So what I've done is I've used name parameters so that I can more easily eliminate or avoid any of the optional parameters that I don't want to worry about. And I can also call it without using that ref keyword at all. So these arguments are used to create a link to the workbook and display the link as an icon. So I'm going to run it one more time with F5, and what you'll see is the spreadsheet start up just like before. Here it comes. Data's going to go in, and it'll autofit and turn it red. There we go. And then the Word document opens up, and you see that the link is there as an icon. This is the Visual Basic version of the Office demo. So I've opened Visual Studio 2010, the Beta 2 version, on my Windows 7 machine, and I'm going to start a new project. And it's not a Visual C project, it's a Visual Basic project. The type is Office. You can see that I can work either with Office 2010, of course that's not officially released yet either, or with 2007. I'm going to work with 2007, and I'm going to create an Excel 2007 add-in, and I'll call it Office Demo VB. Now, in order to make this work, I have to be using the .NET Framework 4.0, and I did check up here to make sure that that's okay. Now, the first thing I'm going to want to do is add the references that I need. So I'm going to right-click here and select Add Reference. It's a .NET reference. Now, I want to make sure that I find it correctly, so I'm going to sort it here alphabetically. And what I need is Microsoft Office Interop for Excel and for Word. And I want version 12 because that's the 2007 version. Okay, and now I'm going to work with the This Add-in class. And the first thing I want to make sure is that I have the imports that I need. Microsoft Office, and Interop. And now I want to quickly create a new class to hold an account type. So I'll say Add Class, and it's got class selected there for me, and the name of the class is going to be Account. Just a tiny little bit of code here. Property ID as integer, and we'll make that be -1, and property balance as a double. And now I'm going back to this add-in, and in my startup method here, I'm just going to paste in some code that will create a new list of accounts named bank accounts. And here I'm instantiating 2 accounts with an ID and a balance. Now, this shows you using the collection initializers that I talked about in the slides that are new in Visual Basic and Visual Studio 2010. And now I'm ready to export my data to Excel. So I'm going to add another method. Oops. to my startup. To my class here. I'm just going to paste in the code here because it's kind of long, and then we'll look at it. You can see that this sub here takes 2 arguments, accounts, which is a list of accounts, and then the next is an action, which takes 2 arguments, an account and a range of cells. And then the body of the sub here creates a new workbook, and it puts in headers or titles for the 2 columns A1 and B1. The value is ID and balance. Then it moves down to the next row. And then for each account in that list of accounts that pass in, it loops through the list, and it calls this display action method right here, passing it the account and the cell. Remember, display action wanted to get an account and a cell, and display action obviously knows how to display that account given a starting cell. Now we'll have to look at how we write that display action in a minute. And then it moves to the next row and continues through that loop. And then in the last 2 lines, first of all, we're copying all of the data to the clipboard, and that's just hard-coded in the range, and that's just to make the code simpler. and then we're using Autofit to fit the columns to their values. Now, the sub has an example of an optional parameter. There's an optional parameter to this add method that we didn't use. When I hover over it, you can see that. See template as object. And it also uses indexed properties, like this value right here that is used with range and with ID. And then in the last two lines, we're using a dynamic type to adjust those column widths to fit their contents. When we created an Office project, the value of embed interop types was set to true. And because the comm call here to get that column 1 is going to return an object, then we would have to cast it as a range type in order for Autofit to work. See how it's nothing but an object? And Autofit can't be called on an object, but at runtime, because of the embedding interop types, it will automatically cast it to a range so that Autofit can be called. Now, all of those are new features in C#, and that's why they're here in the demo, but they actually aren't new to Visual Basic. So we're just going to go on to the next step, which is calling this sub. So I'm going back to the startup method up here, and what I want to do inside startup is call display in Excel. And it's kind of long, so I'm pasting the code in here. You can see that display in Excel takes two arguments, a list of bank accounts, and then you may remember from before, after the list of bank accounts was an action that itself took two arguments, an account and a range. So here's the list of bank accounts, and here's the action. It's been written in line as a lambda. And that action takes, it has no name, it's just sub, but no name, and it takes an account and a range. Well, that range is being passed in as a single cell value, but that's a range. And then what it does in the body here is it formats the account and places it in the range. So what it basically does is whatever cell is passed into it, whatever range is passed into it, but it's a single cell, gets the ID of that account that's passed in. Then it moves over one and puts the balance there. And then if the balance is negative, then it takes the cell's color and colors it inside as pure red, and then moves over to the next one and also colors it as red. So right here in the call is the second argument being passed to it, where I'm supposed to supply a list of accounts and a method. I'm supplying a variable to hold the list of accounts, and then I'm supplying the actual code for the method. So that's an example of a lambda, a multi-line lambda, a lambda that instead of just having an expression in it, actually holds statements, and that's a feature that's new to Visual Basic in 2010. Now let's test it. We're ready to test it. I'm just going to press F5, and what should happen is Excel should open up, and it does. And then it's going to put those two accounts in and format. And now I'm going to add one more thing. Let me close that. Don't want to save that. Going to go back to my code. So here at the end of the startup method, I'm just going to paste in a few lines to create a Word document with a link back to the workbook. Now, this call here to paste special uses named arguments. Links and display as icon are named arguments, and because it's using only 2 out of the 7 possible arguments to this method, it's also an example of optional parameters. And now we're going to run it. F5, and Excel should start first and give us the data on those 2 accounts, and then a Word document should open with a link, and there it is. Here's some more resources you can use to learn more about Visual Studio 2010 and Office programming. Here's where the first link, here's where you can download the Beta 2 version of Visual Studio 2010. And for more information on writing Office solutions, there's lots of information on MSDN. These first 2 links, or these next link 2 and 3, they'll help you get started. Now, if you'd like to download the newest version of Office, which is 2010, there is a free, fully functional beta version available at this third link here, or this third bullet here, but it does expire on October 31st of 2010. And then the last link is for walkthroughs for Visual Studio that includes the demonstration from this video, along with several others. And the source code for my demos from this video and others are also on my blog at the URL shown here. And I announce on Twitter as new videos are posted. So if you'd like to know that, follow me on Twitter at nstrickland1. And that's it, I'm done. Thanks for watching. Bye-bye.